All right, guys, so we are moving on. For such a time as this, we get to move on to exponents and logarithms, and that is what we're seeing in our nation today. We are going to start on lesson 10.1, and I don't have notes for this, so we are moving on to rational exponents. So we are just starting fresh, and I am going to work with you on this, and we're going to do awesome. The first thing I'd like to show you guys is the square root of a is the same thing as a to the 1/2. Remember that there's an invisible 2 inside here, an invisible 1. So what the book does is they throw it to you in a totally different manner. They say b to the p over q is equal to the q root of b, all of that to the p, which is equivalent to the q root of b to the p. So I think that's a little bit more difficult to see how that's working, but we are going to learn how to do this, and I'm just going to give you a hint. You could put all of this right in your calculator, which is wonderful for right now. Now, if we were taking our ACSI, you would not be able to do that. So appreciate the times that we're in. But let's go ahead and see what's happening. We're going to do it by hand in example 1. Example 1 is saying 81 to the 3/2. So the first thing, because your amazing math teacher made you memorize all your perfect squares and cubes, you know that 81 is the same thing as 9 squared. And if all of this is to the 3/2, remember that anytime I have a power to a power, we can multiply. So super cool, the 2's cancel out, and we know 9 to the 3rd power, we might not know that, is 729. And that's how we would do example 1. Now, what happens if we get something like example 2? All right, example 2 says 8 to the negative 5 over 3. So we have to look at this 8 and say, we want something to this bottom power. Now that we've seen how it works, we know we want 8, something to the 3rd power. Because I made you memorize this, and this is why I was preparing you all for this day, I know that 8 is 2 to the 3rd power, and all of this is negative 5 over 3 to the negative 5/3 power. So notice, because a power to a power, we multiply. Going back to the laws of exponents, this and this can cancel out, and we have 2 to the negative 5th. Well, a negative tells me to put it on the bottom, and 2 to the 5th is 32. All right, I'm going to move on to some other ones here. Let's look at example 3. Example 3 says 6x to the 2/3 is equal to 54. The first thing I'm going to do here is what your gut tells you to do. I bet your gut is saying, hey, we're solving for x, so we have to divide each side by 6, and that is correct. So we have x to the 2/3, well, 54 divided by 6 is 9. Now to solve for this, because we know when we multiply, we can cancel out, I know that I'm going to multiply this to the reciprocal. Because when I do that, the 3's will cancel out and the 2's will cancel out. Well, from prior knowledge, I know that 9 is 3 to the 2nd power, and all of this is to the 3/2 power. So I'm going to cancel that out, and x is equal to 3 to the 3rd power, which is 27. All right, we're going to look at one more solving equations using rational exponents. If I have, oops, I'm on example 4, I believe. If I have a minus 4 to the 2/5 minus 3 equals 1, well, what does your gut tell you to do first? We're solving for a, so my gut says, hey, let's add this 3 over. So I have all of a minus 4 to the 2/5 is equal to 4. And what's your gut saying now? Hey, if we have a power of 2/5, I know I can multiply by the reciprocal. And the 5's cancel out and the 2's cancel out. So on the left side, I just have a minus 4 left over. And I know that 4 is 2 squared. And so the 2's will cancel out. So we know we have a minus 4 is equal to 2 to the 5th power, which we just found out is 32. 2 to the 5th power is a good one to remember, just in case you forget. And you're right, when I add 4 over, a is equal to 36.